All right, everybody, welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm here with Dr. Moshe Hoffman. He is a research scientist at MIT Media Lab and lecturer at Harvard's Department of Economics. He applies game theory, models of learning and evolution, and experimental methods to try to decipher the incentives that shape our social behavior, preferences, and ideologies. He also co-designed and teaches game theory and social behavior, which lays out a lot of the evidence and models behind this approach. So, Dr. Hoffman, thank you a lot for taking the time to come on the show.
Thank you.
Okay, so the first question I would like to ask you is, what is game theory, and what are some of the main differences that you would like to point to between game theory and other approaches to study human behavior?
Yeah, so game theory is just like a mathematical toolkit, and I guess though many approaches to understanding human behavior, but I just think of game theory as just like a tool that can help any approach, right? So it can be used in the standard economic way of thinking about things, where you look at how people consciously make decisions, optimizing trade-offs, and game theory can help you with that analysis, or it can help a biologist who's analyzing animal behavior and evolving traits. And game theory is just going to then be a tool whenever payoffs or incentives come into play, and when those payoffs or incentives depend on interacting agents. So that will happen with firms bidding on radio wave spectrum, or it'll happen with animals fighting over territory. And in my case, as someone interested in human social behavior, it happens. Payoffs and incentives influence. I'll argue, and maybe this is something we'll go into more, shape a lot of our ideologies, our preferences, our beliefs. And game theory comes into play then just as a mathematical tool that's useful for those kind of settings, because the payoffs and incentives in those settings are social and interactive. So just a tool, but of course you need a lens to know how to apply that tool. And in animal behavior, that lens is evolution of biology, and in firms, bidding on radio spectrum, that could be auction theory or IO or something like that. But yeah.
Mm-hmm. Okay, so since you just told us that you're very interested in understanding a bit better how human social behavior works, do you in game theory also take into account certain things that go around in our mind, certain cognitive aspects that we've learned through disciplines like, for example, social psychology, like our biases and heuristics and things that we tend to pay attention to, and the ways our decision-making processes work? When do you use that then to perhaps predict through iterative interactions between people in a group how those interactions will develop and evolve over time? Is that it or not?
I guess, and tell me if I'm misunderstanding your question. The way that I think about social psychology and the phenomena that are documented in that field or related fields like JDM, judgment and decision making, is that those fields document really interesting phenomena. Phenomena like the heuristics that we use, that I don't know, CUNHA and Tversky might talk a lot about, or many other people in JDM, or other phenomena like cognitive dissonance or motivated realism or things like this, motivated reasoning, that social psychologists have done a really good job documenting. So I'll kind of take those things as given and look at all the features that they might have. And then I would try to do something that's kind of one step further, which is an analog that I guess many evolutionary psychologists would be familiar with. Is I would ask, okay, why does our brains work like this, or why do our beliefs work like this, or why do we use this heuristic, or why is this feature something that would have been selected for? And so, I very much appreciate those disciplines and what they've had to offer, but I, like other people in the evolutionary psych tradition, like to go a step further and ask why.
Okay, so we can use game theory, it has an explanatory power in regards to human behavior, right? I mean, we can use it also to find out what are some of the main strategies of social interaction that humans, and also other animals, but since we're focusing here on humans, that they have evolved, correct?
Yeah, but again, I guess game theory, I like to think of it as like a tool, and then like how you apply it depends on like what setting and what set of assumptions you have in mind. So if you're applying it to firms, choosing how to bid for radio rave, then you're gonna have to think about like conscious optimization and like what motive would they have to like bid optimally, like what kind of constraints do they have on like the ability to calculate like are there principal agent problems or things like that. But I usually apply game theory in the realm of human social behavior to understand things like these biases that social psychologists or JDM people have talked about, and then you might ask, why is game theory relevant to those settings? And I think that requires a little bit of thought, and maybe something you and I can discuss more or debate even. But I think of it as learning or evolutionary processes that shape our minds. And then if they shape our minds in a way that kind of is reflective of the incentive structure, perhaps because incentives in biological evolutionary contexts correspond to fitness, or in learning problems might correspond to like primary rewards or things like that, then game theory is going to come into play if you want to better understand those learning or evolutionary processes. And so for many of the biases that people in JDM or social psych have documented, those are biases that I think were shaped by some kind of combination of biological evolution and cultural evolution or learning processes like reinforcement learning. But in those cases, if these different processes are shaping our minds to create those biases, I would use game theory as a mathematical tool to help disentangle what are the different incentives at play, and to help disentangle what could have led learning processes or evolutionary processes to lead to these features of these particular biases. So game theory in a way is kind of like a tool that I use to go from these puzzling features to the learning or evolutionary processes, if that makes sense.
Yes, it makes sense. And would you say that game theory, in comparison with other behavioral sciences, what it does is that it really gives us a mathematical model of how people interact? Because I mean, I guess that in other sciences, and we've already talked here about the biases and heuristics that people in social psychology and cognitive psychology discovered. But I guess that in those areas, they don't tend to present things in terms of mathematical models, but simply say, oh, we've discovered that people have this or that innate bias or something like that. And I mean, they don't really focus too much on studying the social dynamics over time and mathematically modeling it.
Yeah,
right?
yeah. I do think it's a useful mathematical tool, but I guess I just want to also emphasize, and I think you're forcing me to articulate this, that like it's just one of several mathematical tools for helping us understand the way our minds work. I don't think it's the only one, and I don't think by itself it's like fully explanatory. I think it's a valuable one that's understudied in the social sciences, at least when thinking about where the biases of our mind come from. I think it's usually used to model firms and optimizing agents who are rational and conscious and calculating, and also somewhat used in biology to understand animal behavior. A little bit less have the models been developed to understand quirks of social cognition and things like motivated reasoning. And so obviously there's some work on that, but that's why I think the tools have been particularly underutilized and are particularly in need of further development. But I don't think it's the only tool to understand, the mind, and I think it's a tool only in complement with other tools. It just happens to be the one that I specialized in. So, many people, other mathematical tools that might be relevant are very, very nice, of which I'm only partly familiar at a very low level. Nice models of like reinforcement learning, and there's a lot of interesting mathematics of like, you know, how one would model either the way animals or humans or you know, an ideal robot or AI would learn. And those kind of models also involve interesting mathematics and could potentially teach us a lot about human agents. I happen to not specialize so much in those models, but I think they're potentially a very valuable contribution to also understanding human social cognition. But you know, those are just two: game theory, reinforcement learning. You know, Joe, Henrik, Rob Boyd, these people kind of develop models of cultural evolutionary processes and social learning, and I think that's also potentially you know, a very, very valuable toolkit. And then you know, many others, but those are three that I myself know a little bit about and have looked into. But they all kind of require a little bit, not just the mathematical tools, but also the lens. So you kind of need to think about, why would these models be relevant? How do you interpret them in these contexts? Because you can't just, you know, take game theory from an econ textbook and then immediately understand, you know, social cognition, because the econ textbooks aren't written to understand social cognition, and there's a lot of kind of interpretation that needs to go on with it, and of course that's going to complement other fields that other people have developed, like, you know, evolutionary psychology. You kind of need to be able to think about, like, you know, the mind obviously isn't a tabula rasa. So what counts as an incentive is going to be something that evolved, you know, and that requires understanding of evolutionary psychology, or maybe cultural evolution, or reinforcement learning, or other toolkits and ways of thinking in order to bring the game theory in and make it sensible. Yeah.
Mm-hmm. Yes, it's interesting that you just referred again to evolutionary psychology, because I would like to ask you. So, from an evolutionary perspective, we know that the strategies of interaction that people use in society depend a lot on the incentives that underlie them, and these incentives are influenced, I guess, by, we could say, I think, by our innate proclivities, innate preferences, and the information we collect from our environment, and how our innate cognition processes it, in this case regarding the social realm, let's say. But there's inter-individual variation, that is, variation among individuals in terms of the strategies that each one of them prefers, and perhaps in a given society one of them is more prevalent, and in another society there's another strategy different than the first one that is more prevalent. So does game theory also help us to predict? So if we have a certain percentage of individuals following a certain strategy, and another percentage following the opposite strategy, let's say, does it help us predict perhaps how that society will evolve over time, in terms of if one of the strategies will prevail, and if 100% of the individuals will start following it, or the opposite, and things like that?
Yeah, I mean, I think it's a tool that offers some insight on that. It's mostly not optimized for, like, understanding dynamic processes and long-term trends. I think well, we can get into discussions of what other models might be useful for that. What game theory I find is most useful for is knowing what maybe two ways to put this. One is like it's equilibrium concepts, which is all about saying, oh, if the population is stable at something, what features need that behavior have? And so it's mostly designed to understand kind of stable populations. And now it might tell you, like, well, you know, if a population is stable and if everybody kind of does something, does things a certain way, then you know, certain features need to hold, or certain constraints need to be satisfied.
By the way, could you just tell us what is a stable society? What do you mean by that?
Yeah, so obviously stable is just, you know, a made-up, you know, mental idea that doesn't actually exist, you know, like the triangle or the perfect sphere or whatever, like it's a platonic solid that's not actually real. But the idea is that if, like, you know, so maybe it's worth giving the definition of Nash equilibrium. So Nash is just like a description of how everybody would behave, such that nobody could individually benefit by deviating if everybody else stays the same. So if everybody does what you expect, would you benefit by doing something that's not expected? And so Nash says, you know, if nobody would benefit from unilaterally deviating, then that's an equilibrium. And so what does it mean for that to be an equilibrium? That means that if everybody expects it, then nobody's going to do anything different, which also means that like if somebody like tries to do something different, they would actually get lower payoffs than they anticipated. So like a reinforcement learning process would like tell them, oh, that didn't work out, go back to what you were doing before. A social learning process would say, don't imitate that guy because he got lower payoffs. Or a biologically evolving process would say, oh, like that mutant like will have less offspring and die out. So the population, according to all three of those dynamics, will then go back to the Nash equilibrium. And so that's the basic premise of Nash equilibrium, is that like if you start at a population of Nash equilibrium either because of like conscious reasoning or biological evolution, cultural evolution, reinforcement learning, you'll stay there. And so in some sense, like it's a description of how everybody behaves such that it's stable according to one of these processes. And so that's kind of like the valuable like explanatory power that it has is it tells you what kinds of things can be stable according to these processes. And so then as a scientific tool, it's useful because then if you see people doing something pretty much, you know, in a stable way, and again, that's a Platonic solid thing that doesn't exist, but maybe in a scientific world that would mean like, oh, you kind of see this consistently over the long term, you kind of see everybody doing it, you kind of see it, you know, fairly uniformly. Like if you see something that looks like a real like feature of society or social behavior or the way people think that's consistent, then okay, that has to be stable according to these processes. And so then okay, then it must be like if you think these processes well, we can argue, but then I would interpret that as, okay, it must mean that things are Nash, and so now we can figure out what are the incentives that could be sustaining this. And so maybe Nash can give us some insights as to like what kind of incentives might be at play. So an example of this might be like, okay, motivated reasoning, you know, is something that we see, it looks, I don't know, I guess we'd have to check, but it looks like it's not just a modern invention of weird society. It looks like it's a fairly, maybe it varies somewhat by culture, but I think of it as probably a human universal that was probably around in our culture for as far back as we look. And so that tells me, okay, it's probably something that's kind of stable according to these processes. And so then you kind of have to ask, okay, what are the incentives that could be driving it? So that's one example of that. You know, another might be like we treat omission different from commission, you know, in our moral intuitions. So why would we consistently treat omission as less bad than commission? We seem to do that cross-culturally. We seem to do that, you know, if you look back historically, you know, I do that today, I'll probably do it in 10 years from now. So it's a kind of a stable trait of human cognition that omissions feel less bad than commission. Okay, then that must mean that it perhaps, you know, if these processes, dynamic processes are at play, then it must be at some sort of equilibrium. And so then I might then ask, okay, well then what could be sustaining this as an equilibrium? And so then I might use some game theory tools to reverse engineer what could be the incentives that shape omissions to be different from commission. So that's an example. Maybe hopefully that clarifies.
Mm-hmm. Yeah, I'm going to repeat the question. I was just asking you, so we have these several different types of strategies in game theory, like for example, tit for tat, walk away, and those types of strategies. When you say that, for example, the individuals in a certain group or society tend to follow the tit for tat strategy, are you pointing toward the fact that they have several different innate strategies, and when they are exposed to a certain social environment, subconsciously they choose and prefer that type of strategy, or that is something that is completely built up by the environment itself, and it's not really that all individuals have these have all of these strategies that they can follow, but perhaps it is the environment itself that creates them.
I see. Yeah. So let me see if I can unpack your question a little bit. So one way to interpret your question is like, is it that our strategies are innate and genetically encoded, or are they culturally learned? And I think in some contexts, or learned by like reinforcement learning, and I think in some contexts it's going to be each. Some contexts it might even be consciously something that you figure it out. So I think those are different processes that could lead to the selection of your strategy. And I think we'd have to talk about, from example to example, which one's the most, which process is the one that's most likely to be at play. But I guess even when it's like socially learned or learned through reinforcement learning, there's going to obviously be some constraint in like the search space. So we're not going to be trying every single strategy. Obviously our learning processes are somewhat limited in what kinds of things they would think to try or think to imitate. So there'll be some goal of like biological evolution in constraining the search. But it turns out that like learning processes are also pretty good at rapidly searching very vast spaces, and are pretty good at collecting a lot of information very efficiently, and so in that sense, a lot of strategies I do think are kind of invented fairly de novo, and again, how de novo will depend on the application.
Mm-hmm. Yes, but even the new strategies that people might create in new environments, let's say perhaps environments that we didn't really have access to during most of our evolutionary history, those are still biologically constrained? Is that what you're saying?
I guess more or less. I think we're pretty good. So I don't think that like every strategy is like picked from a set that was pre-selected by biological evolution, right? So it's not like we either play hawk or dove, and those are the only two, and biology said play hawk in this environment and play dove in this environment. I think that that's true for some contexts. So like, I don't know what for most humans, not all obviously, but for most humans, we have something that kicks in that says be attracted to males if you have two X chromosomes, and be attracted to females if you have if you have an X and a Y, and like that's something that gets turned on from testosterone, in prenatal or later stages in life, or when you develop during puberty and so on, and so that's something that there are. I mean, it's obviously a lot richer than this, but there's basically two different strategies in the sense that you could either more or less, or at least there's a big difference between how males and how females are gonna work for the most part, and that's fairly well encoded in that there's been a lot of like genetic evolution to shape like the different mentalities of males and females, but obviously. So like for some things like that, you can code in this like, okay, if you have an X chromosome, act this way. If you have a Y chromosome, act that way. But like not everything is as easy to pre-encode. So like whether or not like you let's say are attracted to long fingernails as an example that I give in class. So that's something that like seems to show up in like some parts of Asia, Northeast India is where I observed it, where this fingernail and this fingernail are extra long, and people find that beautiful there. And that's not something that like there's a switch in our head that says either be attracted to long fingernails or short fingernails, in the same way that there might be a switch in our head that says be attracted to males or be attracted to females. That's not like there's no such switch. You had to like, kind of de novo culturally evolve this like this sense of beauty, that like a long fingernail is something that is beautiful, and so in that sense it's different from the male-female switch, and it's kind of created more de novo, if that makes any sense. Obviously everything has a mix, and it's a continuum. Even like male-female, whether you're attracted to male-female, there's a huge variation in what kind of person you're attracted to, and so on. But I think you get my point.
Yeah. So, for example, when we read the book The Selfish Gene by Richard Dawkins, and at a certain point there he talks about the experiments that people like Robert Axelrod and others did by doing computer simulations and mathematical modeling, that they arrived at the conclusion that tit for tat was the most evolutionarily stable strategy. What does that really mean there?
Well, I think there they were trying to argue that this idea of in repeated games you can sustain cooperation via something like reciprocity, and we could use a game theory model and a computer simulation of an evolutionary process in that model, that you could get some notion of reciprocity to evolve, and that could explain some aspects of altruism. I think that's right, and that's a very nice insight, and I'm happy to unpack it more for you if you want. I think it's a pretty good use of game theory to kind of better understand how altruism could evolve and what feature it would need to have, like some notion of reciprocity, some notion of there's a future and you'll be penalized in the future for misbehaving today, or rewarded in the future for behaving well today. And so I think it's a useful method to understand how altruism works and how it might evolve. And I think that's quite consistent with the way that I use game theory and think about game theory. There's a few differences. You know, some obviously that study was done, I don't know, in the 70s or something, so 40, 50 years ago. So obviously I think science has advanced since then, and I can tell you things that I thought were wrong with that experiment, or things that I think we've learned since, or that I disagree with. But I think it was a great contribution to science, and I think it's fundamentally the right way to think about, you know, the evolution of cooperation and the elements of game theory to understand social cognition.
Yes, but in that case, when Robert Axelrod says, for example, that tit-for-tat strategy through the computer simulations that he did was the one that was more stable over time, that doesn't really mean that. I mean, over time, the individuals that were part of that specific population, let's say, that some of them didn't try to use other strategies, but perhaps those types of strategies didn't really disseminate successfully throughout the population, right?
Yeah, that's good. So I think that's right. I'm sorry to clarify that, but yeah, in their simulations, they kind of had people. I think in the version of the experiment you're describing, they had people, you know, contribute different strategies, and then they had them kind of play around robin with each other, and then the strategies would reproduce based on the payoffs they got against each other, and then you know, in the computer simulation they'd either become more frequent or die off, and so tit for tat was the thing that became most frequent as all the other ones died off. And so I think that's right. That's kind of like a model of how evolution might work. Is like you have a population that's seeded with a bunch of strategies. You know, in reality, they're probably not all seeded at once. You kind of have some randomly showing up every now and again, but you know, they were obviously doing a simplified model. You know, when a strategy doesn't do well against the rest of the population, it'll become less and less frequent and die off. And when a strategy does well, it'll become more and more frequent. And so that's kind of what they were simulating in their experiment. Yeah, to try and like get at the insight that tit for tat is a strategy that does well against other strategies and against itself, and you can kind of get a stable population of tit for tat agents, and more generally, you can kind of get a stable population of agents that are reciprocating and cooperative, and that, you know, an essential feature of such cooperation for it to be stable needs this kind of like shadow of the future and so on.
Okay, so from a biological perspective, is it also true that game theory can also allow for us to predict? So if we are dealing with a certain animal, like for example humans, and we know in which context, in this case the social context, it is evolving, does it allow us to predict based on that the kinds of strategies that would be favored the most, even in terms of genetic transmission of the predisposition to those sorts of strategies? If I'm being clear here, of course.
No, you are being clear. I think it's an interesting question. I tend to use game theory differently, and I tend to think about it as a science in kind of the reverse way. So let me try and explain the distinction, because I think what you're saying is a perfectly reasonable way to think about it. But I think it works less well when you try that way. So let me try and clarify the distinction. And I think it's kind of analogous to how Darwin or some early evolutionary thinkers might think about biology, which is that it's these tools, the game theory tools that I'm using, or evolutionary theory that Darwin was thinking in, or early biologists were thinking in, is really useful, in my opinion, for explaining things that we already see better than predicting things that we haven't yet seen. And so, in the same sense that I don't think Darwin would have been able to predict, you would get this species there, or in 10,000 years we're going to have a species that looks like this. I think the tools just aren't great for that. In other fields, you do have tools that are really good at predicting the future, or engineering, or designing, or changing the future. I kind of think of the theory of evolution, as well as the stuff that I do, as more good at understanding the things that we observe than at prediction. So more explanatory tools. So if we see something, I can try and reverse engineer what's going on and tell you, these might be incentives that are at play, or this kind of game might be what's driving these kind of features. But with that said, there is still some predictive power, just as I think Darwin had, which is, largely things like comparative statics, which is a term that economists use, which just means qualitative predictions, which means that you're not going to be able to predict to the T what's going to happen, but you're going to be able to say on an island with smaller seeds, you're going to have beaks that are thinner, which is the kind of prediction that Darwin was able to make. And I think that's what the theory of evolution is good at. I think the same thing with the way that I'm using game theory. It can make these kind of directional qualitative predictions, which is to say that in contexts where norm enforcement is less relevant and partner choice is more relevant, the omission-commission distinction should be less pronounced. So that's kind of a qualitative prediction. I'm not going to be able to say this is exactly what morality would be shaped like in this society. It's more of in this context we'd see morality being slightly more pronounced in this dimension and slightly less in this dimension. So again, just qualitative predictions like the beak length and seed size predictions that Darwin had.
Mm-hmm. Yes, but perhaps in trying to predict some general features of our behavior, for example, trying to predict that our species, since we are individuals that from a strictly biological point of view, we weren't really very good predators, at least individually. We don't have claws, we don't have good teeth to catch other animals, and we're not really that strong in comparison with other animals. With that in mind, and knowing that in order for us to be evolutionarily successful as groups of humans, wouldn't game theory predict that we would have to evolve, at least to a certain point, some sort of altruistic behavior or something like that?
Yeah. I think it's true that in human evolution, cooperation was kind of fundamental, and I think norm enforcement likely is a particularly powerful tool that Rob Boyd talks a lot about, I guess the second chapter of his recent book has a lot of evidence for throughout human history and across cultures and stuff, how much it's impossible for us to do anything without strong norms and norm enforcement, and I think that's very true. And I think that game theory is a valuable tool if you want to understand how norms get enforced. And I agree with you that cooperation, which I think an important way cooperation happens is because of norm enforcement, is kind of integral for human society to function.
Okay, so you've been talking a lot about norm enforcement. Could you explain that term? And I mean, does it occur at both biological and the cultural level, or is it something strictly cultural?
So here I'm going to largely talk, just Boyd's view. But if you want, I can add in where game theory, my particular game theory models have added to this. But for the most part, I think I'm just stealing from him, which is that and obviously not just him. I just recently read his book, but he's working with many colleagues. But I generally buy the story presented in that book, which is that norms. We have some kind of evolved psychology for norms that, like an evolved psychology of language, helps us acquire them, helps us to be prepared to imitate them or to spot them and things like that. Tells us what kind of features they're likely to have and so on. So it's not a blank slate view, but the content of norms seems to be very much culturally evolved. And very, very sensitive to the context of what norms get enforced and how much you enforce them and in which cases you enforce them and things like that. So the general psychology of being able to enforce norms seems biologically evolved, but the content seems very much culturally evolved. And then maybe just to relate it back to an earlier question you asked about tit for tat. I kind of think, and I kind of hinted at this, that there's a few things that I think were missing in that original story by Dawkins, which again, I very much, and Axelrod and those people that he cites, very much a valuable story. There's a few pieces that are missing. One is that, in that story, there isn't that much variation in content, right? You either choose to cooperate or defect. It's a very simple choice in each stage. And then tit for tat is a very simple strategy, which is you cooperate against someone if they cooperated against you in the past. And the game is very simple. And there isn't much room for cultural variation in content there. And so that's one reason why it's while a great starting point, it isn't rich enough to understand, to help us grasp, why we get penalized for littering. Right? There's clearly somewhat of a disconnect between that stylized model and a model that allows for more rich content. Which isn't to say it's a bad starting point. It was obviously very good. There's no way we would understand what we do now without that simple stylized game. But it's missing this kind of rich content. Another thing that's missing is it's two-player. It's dyadic. And so I choose whether to cooperate or defect. You choose whether to cooperate or defect. The two of us repeat. But in society, you're usually not just interacting with one other person. When I littered in high school, some guy pulled up his truck in front of me. I'd never met him before in my life. I'll never meet him again. And he told me to pick up the litter. That wasn't a dyadic interaction. I don't really think his behavior is like a spillover from evolved psychology of a dyadic interaction. I think you really need a richer model to capture that. And I think that requires some kind of model of norm enforcement that is slightly richer than the tit for tat. Repeated prisoner's dilemma, but similar game theory tools and similar insights are going to come into play if you want to model norm enforcement, like the shadow of the future and some notion of conditional behavior, where how I get treated tomorrow depends on how I behave today. So some insights will carry over, but it's going to be I don't know if that did that address what you asked me.
Mm-hmm. Yes, and I would like to pick up on that last part, because I mean, pitting biological aspects against cultural aspects of our behavior and our nature. I would like now to establish a bridge with a recent thread you made on Twitter. I think it was in December, about evolutionary psychology and some of the problems that you point that it has, at least. So at the very beginning of the thread you say, and now I'm going to cite, in particular, EP is one of the few fields in the social sciences that attempts a sound and unifying approach that is tremendously valuable and desperately needed in the social sciences. So just before we get into the criticisms, and then perhaps we can pick up on some good examples also to explore a little bit more game theory, what would you say are some of the strongest parts of the evolutionary psychological method? let's
Yeah,
say.
I think I wanted to say I think that you just said it well, but you were quoting me, so I guess I'm complimenting my past self. I like what I said in that tweet before I criticized evolutionary psych. I think I summarized what they're doing well, which is it's a theoretically sound approach that is that is unifying. And I think any good science needs to have that, and that's desperately needed for human psychology and social behavior, sociology, anthropology, and stuff. I think the social sciences desperately needs a unifying approach. And I think evolutionary psychology, as it was built by Tooby and Cosmides and people like that, you know, a generation or so ago, did offer that. And for many parts of human psychology, I think it succeeded very well at that. So I think our understanding of mating, for instance, or attraction and sex differences, these kind of topics, I think it's really impossible to understand without evolutionary psychology. Evolutionary psychology obviously misses some details on it, but I mean, you know, Darwin missed some details on how biology works. But I think fundamentally it's the right approach to give a unifying understanding of these domains. And it's theoretically sound. It's exactly, you know, our minds seem to have biologically evolved for attraction and mating and sex differences and stuff. And so it seems, and you know, the way they're thinking about mental modules and things like that seems to really fit there. So theoretically sound, unifying, I think it's extremely valuable there. I don't know if you wanted me to jump in on where I think it's missing yet, but maybe you were about to ask.
Yeah, I'm about to ask you about that. So the first criticism that you point toward, I guess, is that at a certain point you say that the approach that evolutionary psychology has to human behavior, that it is best understood through pre-adaptations, that is, evolved responses to environmental cues based on ancestral experience and selection. So what do you mean there by pre-adaptations? And I'm asking you this because I've already had a lot of evolutionary psychologists on the show, and for me at least, it isn't really clear what you meant by this term there.
Yeah, I agree. So maybe we need to develop a new term. I kind of just like invented that in the thread, and it's not obvious to me how to word this. So maybe you'll help me with that. But it relates back to like some questions that you asked me earlier in this conversation, and maybe you're already kind of thinking about trying to see this difference. But you know, when I was talking about fingernails versus like male-female sex differences, that like you know. So some things in biology are coded that like just everyone always does the same thing. Like we all breathe. Like as soon as we come out of the womb, like parts of our bodies are just structured so that we start breathing. And there's no variation in that. There's no like, that's just something that we clearly evolved to breathe. But some things are very like, require a switch, and that only sometimes some of us do it. So like being attracted to females is something that most males do, but most females don't do. And so there's a switch, maybe it's not as 0-1 as I'm describing, but there's a switch of sorts that tells our brain, oh, be attracted to females, oh, be attracted to males. And that switch, so it's not the being attracted to males that's something that's like universally human trait, but the switch, the being able to either be attracted to males or females, seems to have been something that was genetically coded for. And in fact, whether the switch gets turned on or off seems to depend on something like prenatal androgens, or maybe androgens during puberty. So there's a switch, what sex you're attracted to, and then there's like certain features of the environment that turn it off or on, like androgens at different stages in development. And all those things were kind of pre-adapted in the sense that like biological evolution in our ancestral history had to deal with the fact that sometimes our genes showed up in males and sometimes they showed up in females, and they needed to act differently in those two cases. And so you know, the genes you know figured out through biological evolution a way to kind of code in, oh, behave differently, be attracted to a different type if you're in a different body. You know, namely, if you have male genitalia, for the most part, you know, be attracted to females. And so, you know, detect whether you're male genitalia, maybe by the presence of testosterone, and behave differently. And so that kind of that switch is something that we had in evolutionary history dealing with this problem, namely that we sometimes show up in males and sometimes females, and we dealt with it by having a switch that says, okay, be attracted to males if you have testosterone exposure. Obviously, I'm oversimplifying, but that's the basic idea. There's a switch that we encoded because our genetic history had to deal with this problem that sometimes our genes show up in both males and females. Okay, so other switches that might happen is, I don't know, maybe you're born in an environment with a lot of resources or little resources. So life history theory talks about, like, in those two different cases, there might be different optimal strategies. If you're in an environment with a lot of resources, maybe you know, you don't need to stress out as much. You can plan to live a long life. You know, have good, be very careful what you do. There's no need to take extra risks, things like that. So different optimized strategies for an environment with either high or low resources. That's something we could then evolve a switch that says, oh, if you're in an environment with a lot of resources, turn on this set of features, like be more cautious and less stressed. And plan to live a long life. Whereas with a few resources, okay, a new switch turns on that says, okay, be very, like, take a lot of risks, do whatever you can to, like, amass resources quickly. Okay, so that's a pre-adaptation in the sense that our evolutionary history had to deal with both environments with a lot and a little resources, and so had to kind of adapt to have a switch that tells us behave differently in these two different cases. Okay, but I think that there are many instances where we seem very well adapted, but not in this sense that, like, in our evolutionary history, we had to deal with this problem. Rather, we have a learning module that says, okay, figure out how to deal with problems. So an example that I mentioned earlier is long fingernails. Like, I don't think that, like, in our evolutionary history, we were sometimes in environments where people thought long fingernails were beautiful, and sometimes in environments where people didn't think they were beautiful. And there's a switch in my brain that says, check if people like long fingernails. If they do, grow them. I don't think such a switch exists. Instead, what I think happens is, like, there's some kind of, like, social imitation process going on where we have a general learning module that says, like, get your sense of beauty from other people, do things that people find beautiful if you can, and that generalized notion of beauty kind of then socially gets learned and culturally evolves. And so then, you know, the ability to socially learn it is a biological adaptation, but the content of it, namely whether or not you like long fingernails, is not something that's like a biological adaptation. That's culturally, that content is culturally learned. And by pre-adapted, I just meant it's not like we had a previous environment where we faced this exact problem of long fingernails being beautiful. So hopefully that example clarifies. And if you have a better term than pre-adaptation, I'm happy to take it.
Okay, but just to try to make this clearer for people who will be watching or listening to this later, so would you, for example, call an adaptation something like, I don't know, in terms of beauty, evolutionary psychologists refer a lot to, in women, how men like women with neotenous facial characteristics, or a waist to hip ratio of 0.7, or clear skin, large breasts, and things like that. So those types of things, since we were constantly exposed to that during our evolutionary history, that for you would be a proper adaptation. But but things like, for example, as you said, longer fingernails, I mean, since at least as far as we know, we weren't really directly exposed to that during our evolutionary history and during the Pleistocene and things like that, in our environments of adaptation. I can't remember now the proper term, but it's something like that. That is the environments we evolved and are adapted to from an evolutionary perspective, that all of the things that we nowadays consider beautiful in different societies that were not really part of that ancestral environment, if evolutionary psychologists try to explain them on the same basis, that would be something that you call a pre-adaptation. Is that correct?
I think that's right. And so all I was trying to do with that terminology was to differentiate between differentiate between things that are adaptive because of biological evolution, which requires, kind of by assumption, that it's a problem that we faced in our evolutionary past. And things that are adaptive, not because of any experience in our evolutionary past, but only because of some real-time learning process like social imitation or reinforcement learning. And so I was kind of trying to differentiate these two different ways in which you can get adaptations. I was calling pre-adaptation anything that is biologically evolved because that requires that it was done in the past based on evolutionary past, as opposed to a contemporary adaptation that kind of just shows up and in real time we're able to figure out through whatever real-time process. To contrast that maybe with many things that are kind of non-functional that we do. So maybe this is a third category: pre-adaptations, I don't know, contemporary adaptations, and non-functional like spandrels. So I don't know, the fact that we're turned on by pornography or that we eat donuts. Those are things that they're based off of adaptations from the past, biological adaptations, that don't really fit well with our contemporary environment. So in our evolutionary past, nude women were things you could potentially reproduce with. Nowadays, you can generate them on computers. That's not something we experienced in our evolutionary past, and so there's a mismatch. And so our psychology of attraction is non-functional in this case. It's built off of an adaptation that doesn't currently fit. And so that's kind of a third class of, you can have pre-adaptations that no longer fit. And I think my main point that I was trying to state in that thread, and maybe just to reiterate here, is that oftentimes, evolutionary psychologists kind of think of it as like there's two options. You can either have biological adaptations or spandrels, mismatches. And I was trying to say, actually, you can have a lot of things that are quite adaptive, that are just adaptive due to real-time processes, like social imitation or reinforcement learning, and that could lead to adaptive behaviors that have nothing to do with that don't require pre-adaptations. Allow for kind of a third class, and I think that third class is of like tremendous relevance in many domains, not in all. So I think for like mating and sexual attraction, perhaps less. We seem to have like a psychology that's more, it's all relative, but more fixed and harder to shift. But with like our sense of morality and our sense of like our political ideologies and those kind of domains, I think contemporary real-time adaptations are much more important if you want to understand those. And I think that that's the real place in which evolutionary psychology has kind of missed a lot of insight, because they're too focused on either pre-adaptations or spandrels. They kind of missed out. There's a lot of stuff that can lead to contemporary real-time adaptations via these other processes, like in domains like morality and if you want to understand politics. So that was the main point I was trying to make. Hopefully it's clearer now, but let me know if you have follow-up questions.